So let's look here at this equation together, number 3. What type of equation is this? Hey, it's a polynomial. How do I know that? Because all the exponents are positive whole numbers. That means the domain is all real. So for every polynomial, it's all real numbers. If I asked you, what is the power term? What would you tell me? Nope. You would tell me the power term is x cubed. What does that tell me about the end behavior? Okay, so as x approaches infinity, is that right or left? When x goes to infinity, is that right or left? So as it goes to the right, what's the function doing? Up or down? And if it's going up, that means it's going to infinity. How about the other one? As x approaches, what is f at x approach? I now know the range. Before I graph, I know the range. Do you know what the range is going to be? Do you know why it's going to be all real numbers? Because one side goes up forever, the other side goes down forever, so it covers every y value. There is no low point or high point in terms of that. There's no floor ceiling. It goes up forever and down forever. We're going to avoid the x-intercepts. Do you know how to find the y-intercepts? If you plug in 0, what number do you get? Now, do you know how you could find the x-intercepts? You know another word for x-intercepts is? Zeros. The first thing I would look at is it factorable? So could you factor this by grouping? If you factored out an x squared, and if you factored out, what would go into both here? Is there a number that goes into 35 and 27? My brain went numb. None, right? So it's not factorable. So if it's not factorable, you could create a list, right? Rational zero theorem, all the numbers that go into 27. I'm going to tell you, because all of the signs are what sign? There are no positive zeros, only negative. Because I know the answer key, I'm going to save you. There are no numbers that go into it evenly in terms of remainder. There's no rational zeros. There's only irrational. Can I show you on your calculator how you could find zeros quickly? Would you allow me to? So, and by the way, if you have Nspire, you're just going to press the menu button, okay? So, can you press algebra? Which one do you think would help me find the zeros? 0. And then I'm going to type in x cubed plus 11x squared plus 35x plus 27. Oh, you know what I'm missing? Is I need a comma and an x. Oh, why is there a... that's what I did. 27, comma x. So when you go comma x, you could have more than one variable here, and you're trying to find the zeros for x. And if you had multiple variables, it would do it there. So x cubed plus 11x squared plus... What did I type in wrong? 27. Did I not type it in right? So what is it showing me is that there are no... Did you get something? So then That's being silly, right? Did I type it in okay? X cubed plus 11x squared plus 35x plus 27. I know what answers I should be getting. There they are. So, I went diamond and then enter to approximate it. And so what are the approximate ones that you would get? Did you get those numbers? Yeah. Negative 5.6 and negative 4.2 and negative 1? Those are the ones we got, right? So can we put those on our graph? So approximately negative 5.6. So approximate where that would be. So 1, 2, 3, 4, 5. So negative here. So I'm just going to round. So it's negative 5.655. What's the other zero? Is negative 4.211. And then the last one was negative 1.134. Alright, so I'm going to put those on my graph, approximate them. Do you remember how we find the turning points? So, if I put this in my calculator, x cubed plus 11x squared plus 35x plus 27, if I put that in my calculator, so diamond F1, and put it, then if I change my window, well, let's see what the standard window gives me. Will I see what the turning points are? So that's good. I know the right end goes up and the left end goes down, so I only have 2 turning points. So if I go to math and I go to maximum, move the cursor to the left and then press enter, move it to the right and press enter, and one turning point is at negative 5 and 2. So what do we call negative 5 and 2? We call that a local maximum. The other one, again, I'm going to press F5, go to minimum, and I'm going to move the cursor to the left, press enter. I'm going to move it to the right. Oh, let's try that again. So F5 minimum to the right, left to the right. So the minimum point is at negative 2.3 and 7 point. That's our local minimum. Oh, that's a negative. So, once I have my zeros, my y-intercept is too big for my graph. Then I make sure I connect this with a smooth and curvy graph. So this graph is increasing from negative infinity to what x value? So I'm going to use negative 5. It's also increasing from this x value, negative 2.3, to infinity. And it's decreasing from negative 5 to negative 2.3. All right, let's try that again with our calculator. Number 4. And remember, because I'm going to upload this video of what we did, if you want to practice with your calculator, you can practice later if you didn't quite get it, or ask me, right, at lunch or after school, so we can figure it out. Number 4. The first thing I notice is the power term is x to the 4th. So I know that as x approaches infinity, what direction is the function going? Up or down? And as x approaches negative infinity, to the left is the function going up or down. So both sides are going up. I know the domain is all real numbers. The range, I don't know yet. Because it's an even number, there's going to be a top or a bottom point that will affect the range. If it was an odd, then it goes up forever and down forever, but this one doesn't. To find the y-intercept, plug in 0 and you get negative 1. And to find the zeros, again, I'm going to use my calculator. So, if I want to find my zeros with my calculator, let's practice that skill again. I'm going to press the home button. So let's go through the steps again. So I'm going to press the home button. See if I can do this without a shine. Then I'm going to press F2. And I'm going to go to zeros. And then I'm going to type it in. So I'm going to type in x to the 4th. Subtract 4x squared, subtract 1. Oops. Then I'm going to go comma x, so it'll find the zeros for x. Then I'm going to go diamond enter. I don't know if that helps. A little bit. So, what are the zeros here? I have a 0 at about negative 2.058. And I have another 0 at 2.058. So, close to negative 2 and close to positive 2, and we have a y-intercept at negative 1. Now, without my calculator, I know the right end goes up, and I know the left end goes up. What I don't know is there are two x values. And even without my calculator, I could plug in to estimate it. What would be a good x value I could plug in to estimate here? And the other one we could use is positive 1. And because the function is so small to work with, it's not too bad. So if I plug in negative 1, and if I plug in positive 1, I'll actually get the same answer. Because when you go to the 4th or squared, you'll get the same number. So it's really 1 take away 4 take away 5. And so both answers will give you negative 4. So at negative 1, go down to negative 4. And at positive 1, the same thing. And now we have our graph. So what is -1, -4, and what is +1, -4? Both of them are called local minimums. Do you know where the local maximum would be? At 0 and -1 would be a local max. We only have a maximum or minimum if the graph is turning at that, right? So it can't be in the middle of an interval. So where is this graph increasing? So I'm going to use -1 to 0. So from -1 to 0 it's increasing. Where else is it increasing? From +1 to infinity. Don't be fooled by this arrow. This one is not increasing but is, so if you covered up that arrow, it is decreasing. So from -infinity to -1 it is decreasing. And from 0 to +1 it is decreasing. So what would you say the range is now? What's the bottom y value on our graph? So the bottom y value, not -1, but -4. So the bottom of our graph is -4, and it goes up to infinity. All right, so I'm going to stop there. Mr. G Math over and out.